when we had a binomial squared, a shortcut again was we take the first term in the binomial, so here was x, and we just square it, right? Then we took the second term in the binomial, here was a, and we just squared that. And because we're squaring it, it's always going to be positive, right? And then the trick here was that we took those two, multiplied together, multiply, and also by 2. So basically here we had 2ax, and we kept the sign as negative, right? So remember that? We took a times x and we have multiplied by 2 because we saw that we got it twice when we did the FOIL thing. So the shortcut was just taking that and multiply by twice, right? Yes, does that jog memory? Katie?
Wait, so first we multiply a by x?
Yeah, so we take this a by x, so we got ax, but then we could see that we had that twice, remember? So we're just going to take that multiplied by 2, right? And then we kept the sign, so it's minus 2ax. So that's our expanded form without having to do FOIL. Okay? So, what is the vertex of this equation? What is the vertex of this equation? The vertex. I know, I was thinking back. But think back to when we did that whole marble on the track. What form do we work with? We work with vertex form, remember? What was the vertex form again?
Y equals a bracket x minus d squared plus c.
Okay. I'll agree with what Mo just said. So remember our vertex form of y is equal to a multiplied by x minus d quantity squared plus c. Right? Does that not look like something like this over here? We have x minus a quantity squared. What's our a value here? It's 1, so we're not writing it. So here we have y is equal to x minus a quantity squared. Can I do this? Am I allowed to add 0 to something and not change it? Perfectly fine. We just don't do it because we want to be clean, right? Nice with our math. But implicitly, that's what's there. We're adding 0. Now, when I write the equation like that, what's the vertex? Well, what's the vertex in vertex form? What's the vertex here? What's the vertex?
D and C.
D comma C? Right? So the real vertex is D comma C? So what's the vertex here?
A comma 0.
A comma 0. Right? A y-coordinate, sorry, the y-coordinate of a vertex is 0. It's sitting on the x-axis. Right? So that's our vertex, A comma 0. Right? Doesn't this form look like that? X minus something, quantity squared, we're adding something to it. Our general form is adding c, here we're just adding 0. So in other words, the y-coordinate is 0. So our vertex is A comma 0. Yes, Kate?
So then why did we have to expand it? If we just got it from the
Good question. Good question. Why? We normally wouldn't. But what happens is, most of the time in real life, our quadratic equations look like that. Right? Rarely ever would you get a quadratic equation that looks like in the vertex form. Okay? Rarely. Okay? You will get an equation that looks like that. So here's another question. For this following quadratic equation, and hopefully it rings a bell because you actually had homework on this, I think sometime in Unit 5, what value of k will provide a perfect square trinomial? of x squared plus 18x plus k. So what value of k do we need that we get this to be a perfect square trinomial? How do we figure that out again? What value of k will give us a perfect square trinomial here? 81? Any other attempts other than 81? Rob?
80.
80?
Am I right?
This isn't, the best bid for going down low or anything like that. You don't want to lowball Genie by 1. Not the purpose. 80, okay, 80. Any other guesses?
Oh,
Any thoughts?
Oh.
square.
We want k, value of k, so that's a perfect square trinomial. 17 now.
Hey, I got
81, so another 81 over here.
X and then by 2, and it's 81, the square root of 81 is 9, and you get 18x, which is what's in the sum.
Say that all again.
Yeah, I
Because
do.
you're supposed to have the two perfect squares at the end. If you take the square root of them, multiply them together.
Okay,
and
so
multiply
stop
them.
right there.
Hold your hold.
So 81 is a good candidate because 81 is a perfect square. Sorry, Rob, 80 is not. Neither is 17. Okay? Nothing. Hey, but that's an indication of we're on the right track already. K needs to be a perfect square, right? So how did you get 81 out of that, though?
Because the square root of it is 9, and then you multiply 9 by 2x, which is 18x.
Okay. Is there a way you could get that started from 18x, though? Divide by 2x, right? So what we're noticing here is that in this previous one, right, 2ax, that's our middle term, right? So here we have 2ax, and that's equal to what in this equation? It's equal to 18x. So we want to know what a is, right? We want to know what a is in here. A happens to be a squared, which is what the value of k is. So we want to solve for a. We decide to divide both sides by 2x. We have a is equal to 9, right?
Where'd you get the 2
Yeah.
Right over here.
Well, like, how do you know to put that
Just
in the
in
next
general, right? Sorry, what? How you know what?
Like, how do you know to put that in the next question? Because that was like a different question.
Because here we're working with a perfect square, right? Well, that's what our goal was. So we know what a perfect square looks like, something like this. X squared, a squared, and this thing in the middle, right? So this thing in the middle here is 18x. This is coming down to 8. In our general equation, it's really 2ax, right? What's happening really is you're taking this middle number, 18, dividing by 2, and then you're squaring it. So a squared is equal to 81. So therefore,
Oh, that's what I meant.
y is equal to x squared plus 18x plus 81 is our perfect square. Okay? So basically what you really do is you take this number, 18, you divide it by 2 and you square it. So you get 9 squared, you get 81. That's how you figure out that value for that perfect square. Okay? How can we check? Well, we can just factor this, right? Check. So I'm going to say, well, what's the square root of x? Sorry, what's the square root of x squared?
What's going on?
X. What's the square root of 81? 9. Was 9 times x times 2, does that give me 18x? Yeah, so that gives me my perfect square. Right? So we could come down here and it says, well, this is really the same as y equals x squared. Sorry, x plus 9 quantity squared. X plus 9 quantity squared. Okay, if here was 81. Okay, so k was 81, we got our perfect square. Does that sort of make sense? Making sense? Not really?
Not really.
So where's the confusion? How we got 81?
No, I think how we got 2AX, I'm still kind of. Like, is it just a rule?
Well, no, that we see in general here, right? This is a perfect square. It looks like something like this. A perfect square looks something like this, right? It's basically a binomial being squared, right? And when we expanded it, we got this. So we had something squared plus something squared, and this thing in the middle minus 2ax, right? So in general, that's what we get. We got something squared here. We need something squared here, which was k, but this middle term was 18x. So in general, we need to figure out what the a value is, because what we saw here was a was being squared to get that final value, right? Right? A was being squared, so we need to find out what the a is. So in general, we got 2ax. But the general thing is, I mean, if the x is confusing you, just think you need that number, divide by 2, and square it, as long as your coefficient on x squared is what?
1.
Yeah, as long as your coefficient x squared is 1. Okay? So that's how we get the perfect square trinomial of this.
If you take the middle number and you divide it by 2, does that give you value A?
Yes, that gives us the a. Exactly.
So it gives you the value of K, technically.
No, but k is actually a squared here, right? Because that's the thing without the x. So that's what we had to square it at the end, right? So that's where we had to take that 9, then we had to square it afterwards to get 81.
So once you get the K slash A value, then
So you're left with this, right? X squared plus 18x plus 81. And here I'm checking that, well, that is my perfect square of x plus 9 quantity squared, right? So what's the vertex of this then? What's the vertex of this equation?
9 dash 0. And 0.
Not quite 9. No.
Oh, negative 9.
Yeah, what's going to make this 0? Right? So the vertex is minus 9, 0. Okay? So we can usually go from an equation like this, if this is a perfect square, like this equation here, and get what the vertex is. Right?
Where'd you get that?
Because what is
It's
it?
like A squared.
What is it that's going to make this 0? So same thing that we did with the other thing, right? In the video, finding that 0 point for x. Right? So again, that part equal to 0.
9.
Okay? Question, Daniel?
We divided 18 by 2.
Listen.
Okay, well, before I answer the question, need everybody paying attention, please. Sorry?
We divide 18 by 2, but it has coefficient of more than 1. Let's say coefficient 2.
We'll get there. Okay, but do you understand at least this? What is the coefficient of 1? Okay?
Where is A?
So we have a perfect square trinomial, right? We could factor this easily, right? That was all last unit, right? So we recognize that this is a perfect square trinomial. Take the square root of this. Sorry, take the square root of this. Take the square root of that. Keep the sign, and we'll have a square. And now we can find the vertex. Okay? So here's a curveball. What's the vertex of that equation? I don't expect you to answer it, so pay attention. Yeah. The problem is 75 is not a perfect square. That throws us completely off. It would be nice if that was a perfect square, right? It would be nice if it was 81. We could easily factor it. So, what I want to do is I want to rewrite this equation. Have I changed the equation? No, I just put a whack of spaces between the 18x and the 75. Why on earth would you do that? Why on earth would I do that?
Because you're expanding.
Because I'm nuts. No. Well, I am nuts, but that's not why I'm doing it. Can I? I could. I'm glad you can recognize that, and I want you to remember that later on. Not quite what I want to do here. Good? that you see that. So it's a good attempt. It is something that you can do. It doesn't help us though. In trying to find that vertex. Well, what happens if I add 81 here? What happens if I add 81 to that?
You can put y equals bracket x minus
Plus.
plus 9 squared plus
Yeah.
75.
Well, yeah. Basically, what Katie recognized is that this was our perfect square trinomial, right? Perfect square trinomial, PST. That was a perfect square trinomial. But can I arbitrarily add 81 to anything I want? No, math is about truth. We need to keep the truth, right? So how can I keep this true? Good. I can add 81 on the other side. But I could, and you still get the same result. It's going to be a little bit more work. So that's excellent. So instead of adding 81 to the other side, what else can I do? So instead of adding 81 here, and that will make it true. Good job, Dan. But what else can I do to keep this true as well? What else can I do, Nicholas?
You can subtract 81.
Yeah, I can subtract 81. Right? What is it that I'm doing? I need to use blue. What is it that I'm doing here? I'm adding 0. Right? That same trick I did before. I'm adding 0. I haven't changed the equation. The only difference is I'm expressing 0 differently as plus 81 minus 81. Does that not give me 0? Right? So we're doing basic math here, really. But what we've done is we fundamentally changed how this equation looks. So that what we can do now is what Katie said. We know that this is the PST, and now we're left with this over here. So now I can rewrite this equation as y is equal to x plus 9 quantity squared minus 81 plus 75.
But then can
Why
you
did
just
you-
add the
Now I just want to do this one step first, so that right?
Doesn't the 81 minus
Yeah.
81 cancel out? So why do you still have to put the negative 81?
It doesn't cancel because I use it as part of my PST, my perfect square trinomial. But what I can do is now I can simplify my 81 plus 75, and I get negative 6. Now what is my vertex?
9 negative 6 or negative 9?
Thank you. It's negative 9, comma, negative 6, right? This one stays. The y value stays. You need the opposite for that. So now my vertex is minus 9, negative 6. Was this one even factorable to begin with? I don't even know. Right? I don't even know, to be honest. I never tried it. I'm guessing not.
So
Two numbers that multiply to 75 to add up to 18. But yeah, but you need to find that PSI. Yeah. You know what? I'd rather do it this way. So if I'm asked to find the vertex. Question mark.
so whenever you're asked to find the vertex in a quadratic equation, you always use that.
This is just one technique, right? So last class we showed one technique of where you can factor it, find your zeros, find your axis of symmetry, right? And then calculate the y value, and we got our vertex. This is another technique. But why was it important to find the vertex again? Think back to Unit 4. What does the vertex give us?
The direction.
It's not starting, but like, it provides us a lot of information, remember? Right? What was one information that the vertex gave us? Maximum, minimum, right? Leonard? Not quite. That's where a value gives us.
But if
Right.
you have the two x values, like if you have the two roots and the vertex, then you know
Yeah, so you have your two roots and you have your vertex, then you know what's going up or down as well. Good. Now we're thinking ahead, actually, right? But remember that vertex tells us so much is where the parabola is the lowest point, highest point, right? Lowest, minimum, max. Remember all those terms? Axis of symmetry, right? So basically now we've come full circle, starting from unit 4 with vertex form, understanding what that meant, and getting back to there because we know that told us so much about a quadratic, so much about a parabola, right? But most of the time we're given equations that look like that. Okay? So it's understanding what that form meant, and now how we're going to get there, so that we get all that information. Any questions on that example? Clear? Yeah. So let's try to find that. What is the vertex of the following quadratic equation? Y is equal to 2x squared plus 12x minus 7. Now this one is different. This is what Dan's talking about. Right? Is it easy? Well, first of all, do we have two numbers that multiply to negative 14 to add to 12?
No.
No. Right? Best I could do is 2 and 7, and that doesn't add up to 12. The next thing is 1 and 14. That gives me 13 at best. Right? So I can't quite factor this. Right? So maybe we'll try the perfect square triangle. But the problem is that, yeesh, I got that 2 in front of the x squared. Pretty ugly. How can I get rid of that 2 somehow? Can I? How can I get rid of that 2 somehow?
You can factor it.
Divide which by 2? Yeah. So what I do is I want to factor out. So what I do is now I'm going to do a partial, what I call partial factoring. So when I do a partial factoring on this part. Okay. So now I got y, and I want to factor out that 2. So I've got x squared plus 6x, right? Minus 7. So the 7 stays alone because I haven't pulled out a 2 out of that. So I still got a negative 7, but I just factor a negative 2 out of here. Okay?
You choose not to touch yourself.
I chose not to touch the 7. This equation is still true. If I expanded this out, I still get 2x squared plus 12x minus 7, right? So I just did what we call partial factoring. I only factored part of that polynomial. I took out the 2. Now, was 2 the greatest common factor? No. I left the x in there because I still want to keep what's inside here a quadratic. Now the question is, how can I make this a perfect square? How can I make this a perfect square now? Well, y is equal to 2, x squared plus 6x, give it a whack of space, minus 7. How do I make that a perfect square now? Audrey.
You do plus 6x minus 6x.
We're not doing anything with the x.
Okay, so
Well, plus 6 minus 6 is not. So 6 divided by what?
2,
2 gives us,
3,
and we want to square that, gives us
9.
9. So here we get plus 9 will give us that perfect square. But I have to also do what?
Minus 9.
So question, do I put the minus 9 here or do I put the minus 9 here?
Outside.
Out there.
Inside.
Inside.
Gotta put it.
Because then it fits, then you can do like the minus 9.
Sorry?
Never mind, I don't know.
Oh, sure. Well, you can do the minus 9 what?
I don't know, because like before when we had the negative 81
Right.
75, we
Right.
like simplified it, so I guess you have to put outside the brackets, so you can still do that.
Okay, we put it outside the brackets. So I was we did that sort of, well, there's no really brackets in the other question, but it might make sense because you talk about simplifying with the other number. Can it?
Don't you put it outside because if it's inside then that 2 on the outside will change that number?
Okay, but which, is the 2 going to affect this number as well?
Yeah.
Yeah. So the fact that the 2 is going to affect this number as well, we need to keep the negative 9 on the inside as well. basically we keep treating the things in the brackets almost like a separate entity. We're almost doing this all by itself. So it needs to stay within the brackets. So you need minus 9 here. Okay? So now what we could do is we have a perfect square trinomial. So we have what? X plus 3 quantity squared minus 9 minus 7. That looks kind of weird. Right, so this is where our exercise in simplifying comes in. We want to take the 2 and we want to distribute it to this and that. So now we got y is equal to 2 times x plus 3 quantity squared minus 2 times 9 minus 7. So now we're seeing why it was important to keep the negative 9 inside, right? Or else it would have been 9 off. So we have y is equal to 2 x plus 3 quantity squared minus 18 minus 7. Finally we get 2 is equal to x, sorry, y is equal to 2 times x plus 3 quantity squared minus 25. Now can I tell what my vertex
Wait,
is?
why didn't you multiply the 2x? Like 2 times x and 2 times 3?
Because that's the A value.
Sorry?
Like, because you said you have to bring the 2 to the x and the 3.
No, I just multiplied 2 times this thing here. So I'm left it, right? So you see that this, the x plus 3 quantity squared didn't change? I'm just taking 2, multiplying this whole thing. But instead of taking the 2, I multiply by the negative 9. Right? So that's how I got negative 18 here. Question mark?
Where'd your plus 9 go?
My plus 9 went in to this perfect square trinomial. Right? So here was our PST. And so we changed that, we basically changed that, we factored it and got x plus 3 quantity squared. That's where the 9 sort of disappeared to. Okay. But this other 9 had to stay out. So now what's our vertex?
Negative 3, negative 2.
Vertex is
Negative
right? That's supposed to be a 5. Minus 25. Okay? So something with our question we could not factor. It wasn't even factorable how we could normally do it. We can now find the vertex. That's what we would call completing the square. Right? Finding that value of k so that we get a perfect square trinomial of it. And then we had to make all those adjustments afterwards. Okay? And now that we have the vertex, is this parabola opening up or down? Up. Why is it opening up? Yeah, the 2. Is it compressed or stretched? Stretched by a factor of 2. Right? So is negative 25, is that maximum or minimum? Minimum, because it's opening up. Right? Now we have all this information based on this before. Right? So try this one on your own.